After estimating the main reinforcements and stirrups of the beams, compute for the required tie wire to complete the Steelworks estimation. Welcome to Quantity Surveying. For the given two-bay beam framework, the beam schedule is specified with the stirrups using D10mm rebars spaced at 2 inches, 4 inches, 5, and 6 inches to center line. From the previous videos, we have identified the locations of the main reinforcing bars for the two beams. The lengths have also been specified. Say using the clear span of the beam, that means taking the length of the interior faces of each column. Start the gaps from the left column and the clear span all over 8 to account for the 3/4 of the length of the bottom bar at the mid-span. Across the top of the beam, the left support requires clear span all over 3. Then on the other end, there is also the clear span all over 3 on top, and then another 8 of the clear span at the bottom. Then moving on the next beam, check that the start of the clear span has a column width gap. The lengths are again an 8 of the clear span at the bottom, then a third of CS at the top. The opposite end of beam 2 also has a third of the clear span at the top and an 8 of CS at the bottom. For both beams having the same clear span, the middle gap remaining is a third of the clear span. Now focusing on the main rebars, we can count how many there are in each gap, where the first gap is an 8 of 3 meters. The next is computed as a third of the clear span minus an 8, which gives 5/8 of a meter. The middle gap is 1 meter. Then again, the gaps after are 5/8 and 3/8 of a meter. There are also similar gaps on the other side, as the second beam has the same clear span. That is starting from 3/8 to 5/8, then 1 meter at the middle, then back to 5/8 and 3/8 of a meter. Now identify the quantities of the main rebars starting from the left beam column intersection, where the top bars are counted as 5 and the bottom are 3. The left 3/8 of a meter has 5 on top and 3 at the bottom. The next gap of 5/8 distance has 5 on top and 8 at the bottom. Then there are 2 on top and 8 at the bottom for the middle 1 meter. The 5/8 meter gap right after has 4 on top and 8 at the bottom, with the last gap on beam 1 having 4 on top and 2 at the bottom. That would complete the left beam with the middle column width having 6 top bars and 2 bottom. The next beam has similar conditions. The first gap on the left has 6 top and 2 bottom bars. And this is followed by the 5/8 meter right next to it, having 6 rebars on top and another 6 rebars at the bottom. The middle thirds has 2 top bars and 6 bottom bars, with the next 5/8 meter gap having 3 bars on top and 6 bars at the bottom. And for the last clear span gap, there are 3 bars on top and 2 bars at the bottom. Then don't forget that the column on the right also consists of 3 D20 top bars and 2 bottom bars. After the quantities of the main reinforcements are distributed, let's check the distribution of the stirrups. Take note once more that the stirrups are computed using only half of the beam, as the specification used centerline distribution. Take the first gap on the left, which is 375 millimeters. Laying that gap on the beam with stirrups, we can then identify how many stirrups are there in each gap. Same thing is true with the second gap of 625 millimeters. Then, the rest of the stirrups belong to the 500 millimeter gap to the center line. Now let's start counting the stirrups. The first gap is the column beam intersection, which has a standard number of 3 stirrups. The next gap of 375 mm has 4 stirrups. The next 625 millimeters contains 6 stirrups. Then the rest of the stirrups until the center line will be placed in the middle gap. Relative to this example, there are 4 stirrups to the center line, where the 4th stirrup will not be mirrored, so it will be installed exactly at the center line. So with the mirroring, we have 7 stirrups found in the middle 1 meter. As the stirrup distribution is symmetric, we have stirrup distribution as 6, 4 to complete beam 1, clear span. Again, there are 3 stirrups on the middle beam column connection, followed by the same number of stirrups in the various gaps in the second beam. With the main rebars and stirrups already identified, estimate the number of intersections. That is done by first taking the summation of main rebars in each gap. That's 8 for 5 plus 3, and another 8 bars for the 375 millimeter gap. Next has 5 plus 8, which gives 13, followed by 2 plus 8, which is 10. Also, there is 4 plus 8 becoming 12 for the next gap, with 6 bars from 4 plus 2 to complete beam 1. The middle column has 6 plus 2, which is 8. Do the same with the main rebars in the second beam. The left gap has 6 plus 2 giving 8, with 6 plus 6, and that is 12. The middle span has 2 plus 6, which gives 8, and the next gap has 3 plus 6, which gives 9, followed by 3 plus 2, which is 5. The right beam column intersection has 3 plus 2, which is then 5. Next, rewrite the number of stirrups in each gap. Then how to solve for the number of intersections? With the tabularized approach, multiply the main rebars with the number of stirrups. The first gap has 8 by 3, which gives 24. 8 by 4 is 32, followed by 13 times 6, which is 78. Next is 10 by 7, and that is 70. Then 12 by 6, which is equal to 72. Next is 6 times 4, or 24, and 8 by 3, which is also 24. For the second beam, there is 8 by 4, which is 32, followed by 12 by 6, which is 72. The middle gap contains 8 rebars and 7 stirrups, giving 56 intersections. The next gaps have 9 by 6, 5 by 4, and 5 by 3. Add all these intersections to have 573. Learning the intersections brings us to 90% of the computation. From this standard, the length of a tie wire required for binding large diameters, such as D20, is 300 millimeters. The estimated quantity of tie wire is then 573 intersections times 0.30 meter per tie wire, and convert this into weight by taking 53 meters, accounting for 1 kilogram of gauge 16 GI tie wire. The tie wire is then 1,719 upon 530, or that is 3.25 kilograms.